Okay, this recording is going over work and energy word problems for calculating work. Work is something pretty basic and it's a great introduction to energy because energy cannot be created or destroyed, just changed forms. And work is really a great first indicator of power and energy transfer. So, as you already found in the notes and the readings, work's equation is work equals force times distance, or W equals F times D. Work is measured in something called joules. Okay? Force is in newtons, not in F. Distance is in meters. Okay? I want to go over how we read this triangle. Okay? If we're solving for work, work equals force times distance. If we're solving for force, force equals work divided by distance. If we're solving for distance, distance equals work divided by force. You will need to learn how to rearrange equations, okay? If you're one of those people who just plugs and chugs, so you put everything in and then just solve for that variable, that's fine for now, but once you get to those upper level chemistry courses, they are going to get on you about being able to rearrange those equations prior. So, first things first, we have a book that weighs 1 Newton. I know it seems weird that they say weigh. The reason why when we're talking about work, they say weigh, is it's because work has to already do with gravity, okay? So this is the mass and the force, okay? So whenever we're talking about weighing, we're talking about newtons. Remember, newtons are always force. Even though it says weight, it's going to be force, okay? Your weight is the force of your mass on Earth. That's all the reason why it's saying that. So 1 Newton is going to be your force, okay? And is lifted 2 meters, or the distance. How much work is done? So if we have a force of 1 Newton and we have a distance of 2 meters, all we have to do is plug this into the equation. Work equals force times distance. So all we need to do is have force, which is 1 Newton, times distance, which is 2 meters. Please do not have to type that into your calculator. 1 times 2 equals 2. And remember, force is always measured in joules. If for some reason you would like to abbreviate it, it's just a capital J, okay? You will need to remember that unit. The next problem says a force of 15 newtons, so there's our force, is used to push a box along the floor a distance of 3 meters. So distance is work. How much work was being done? Okay, well, work equals force times distance. So all we have to do is 15 newtons times 3 meters. 15 times 3, 15 times 2 is 30, plus 15 gives us 45, and we're using work, so it would be measured in joules. Okay, now we're going to have to start rearranging this equation at this point. It took 50 joules to push a chair 5 meters across the floor. So 50 joules, what are joules measuring? Is it measuring force? No, it's measuring work, okay? Push a chair 5 meters. Meters is measuring distance across the floor. What force was the chair being pushed? So we know that work equals 50 joules. We know that the distance is equal to 5 meters. We do not know what the force is. So if we're solving for force, cover this up. Force equals work divided by distance. So force is equal to work divided by distance. I want to real quick go over this. You guys later on are going to learn another equation for force equals mass times acceleration. Sometimes you can use different equations to solve for a problem. So if you aren't given work and you aren't given distance, there may be another way to solve that problem. So as we go on through this unit, do not assume that you can't solve it. Just try the other equation, okay? So force equals work over distance. So all we have to do is we put 50 joules over a distance of 5 meters. 50 divided by 5 gives you 10, and force is measured in what? Newtons. Okay, and this is your little cheat sheet for now, okay? A force of 100 newtons, so there's our force, was necessary to lift a rock. A total of, that's not hopeful, is it? We can't really solve that problem right now. So forget number 4. You don't have to do number 4. I don't know what happened there. Number 5, it took 500 newtons. What are newtons measuring? Force To push a car 4 meters or distance, how much work was done? Remember, work equals force times distance. So all we have to do is 500 newtons times 4 meters. 500 times 4 gives you 2,000. What do we measure work in? Joules. All right, last but not least, a man exerted a force of 9,000 newtons. That's our force on a stalled car but was unable to move it. How much work was done? Let's think about that. Our force is 9,000 newtons. We don't know how much work was done. What about the distance? The distance was 0. In order for work to be done, the object must move. Okay? But if you wanted to go ahead and plug this in, we know the distance is 0, and work equals force times distance. So 9,000 newtons times 0 meters gives you 0. No work was done. Awesome. Thanks, guys.